Assalamualaikum and hi sir. Today I will present about our assignment 3, which is feedback bar converter. So first of all, this transfer function for block diagram in bar converter, which contains PI controller, pass width modulator, switch, filter, and load. After that, for the question 2, I will present about the calculation for our assignment. So first of all, the question gives us the input voltage AC, which is 240 VRMS. We choose 50 kilohertz as our switching frequency, and then we have to step down the input voltage. So we use transformer. So the ratio of the transformer is 3:1. So to find the secondary input voltage, V2 is equal to 240 divided by 3. So we got 80 volt for our secondary voltage. So we assume voltage output equal to 30 volt because the question gave us the range of voltage output 0 to 32 volt. And then we must find the V peak for our input voltage. So VP is equal to 80 volt times square root of 2. So we got 113.14 volt. So next we find our duty ratio. So duty ratio is equal to 30, our voltage output, divided by 113.14, our V peak. So we got 0.265 for our duty ratio. After that, we find our resistor. So R is equal to 30 voltage output divided by 5. So we got our resistor value is 6 ohm. Then after we find our resistor, we need to find our inductor minimum value. So we use the equation 1 minus D times R divided by 2 frequency. So we found the value of minimum inductor is 44.1 microhenry. And then next, after that, we must find the actual value of our inductor value. So first, to find the actual value of our inductor, L is equal to 10 times the minimum value of inductor. So we got the value of actual value of inductor is 0.441 millihenry. So after we find our inductor value, we must find our capacitor value. So we use output voltage ripple equation to find our capacitor value. So 1 minus D divided by 8 LCF power of 2. So we've found the value of capacitor is 2.78 microfarad. And then after that, we must find the maximum inductor current. So based on the equation, we found the maximum inductor current is 5.5. And then for the minimum inductor current is equal to 5 minus 0.5. We got 4.5 ampere. After that, we found the voltage for our circuit, voltage output for our circuit is 29.98 by the equation duty ratio times voltage input. This is the list of the value that I have found based on the calculation. This is for the duty ratio, inductor, capacitor, maximum inductor current, minimum inductor current, and voltage output. So after that, for the transfer function of buck converter, so we must set our RC2 is equal to 0.5, and then we must find gain by equal to Vin divided by LC. So voltage input for our circuit, which is 113.14, and then the value of inductor that we found before, 0.441 milli, times with the capacitor we found, 2.78 micro. See, we got 9.2285 times 10 power of 10 for our value of gain. So this is the value of transfer function. 1.39 micro S plus 1, 1.0833 S power of 2 plus 61085.8 S plus 0.8157 times 10 power of 9. So after that, for the butt plot circuit, so we must choose 0. So I choose 0 at 60,000 and K1 equal to 10,000. So to find the KP, we need to equal K1 over KS. So 10,000 divided by 60 80,000. So we got 0.167 for our KP. So to make the loop become stable, we choose the phase margin at 45 degree, and then we use 20 log 10,000 is equal to 80 dB, and then 80 dB minus with 35, the value of 35, the value that we found from the unstable loop, so is equal to 45 dB. And then K1 we got, for the new value of K1 for the stable one, we got 177.83. And then for the value of Kp is equal to 177.83 divided by 60,000. So we got, for the new value of Kp is 0.003. So that's all for my presentation. I will pass my presentation to Afiq Iswadi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Iswadi, and I will continue what my partner just explained just now. Right, so I'm using a MATLAB for simulation for bug controller. So this is secret of stability, or its stability. So there is PID, PWM, and bug. At the end is scope. So we double click at PID, we put the whole proportional, integral, and differentiator, which is 0.2, 10,000, and 0. We right click, okay. We double click at PWM, we put 1 as voltage PP. At bug, we double click, we put within 113.14. Inductor is 0.441 milli. Capacitor is 2.78 micro. Resistor is 6. SR is 0.5. Alright, so after we put the value, we run it. I click the model linearizer, and we get this. After we click the block, we click the board diagram. So for this is a board diagram for unstable. This is, we can get magnitude dB is 34.9 dB, and its phase margin is negative 133. So for stable, I get negative 0.193, and the phase margin is negative 134. Okay, this is a secret of bug controller. This is a design of bug controller secret. Double click at PID, we put 0.03 at proportional, integral 177.80. Okay. Resistor is 6 ohm. Inductor is 0.441 milli. RC is 0.5. Capacitor is 2.78 micro. Alright, then we run the program. So we get this for the scope, the middle scope. So we double click at the middle scope, we get this waveform. The upper waveform is duty ratio, and the our waveform is feedback and repeating waveform. So the upper waveform is like a box, and the lower form is like selection, which both have peak and lowest point of value. Right, we continue with scope B, is we got this waveform. We have two waveforms also. The upper waveform is current measurement, and the lowest waveform is the lower waveform is voltage output. So we calculate the maximum of inductor current. We got 8.8. The maximum inductor current is 8.537, and the minimum for inductor current is like approximately 8. Right, the minimum is 8. So we move to voltage measurement. We got the maximum voltage is 50.19, and the minimum voltage is 49.48. Right,